Right, we got an overview of the different types of graphs. We learned how to complete the square. Now we're going to look at putting the two things together, the completed square form and the graph of a quadratic function. So you'll see here, we have got a U-shaped graph, which we know is quadratic. It is an x squared term. Over here on the right, we've got the general form of the quadratic, x squared plus bx plus c. An example we have is this one here, x squared plus 4x minus 6. If we were to write this in the completed square form, which you now know how to do, it would look like x plus 2 all squared minus 10. Now let's look at the minimum point, the turning point of this quadratic. The minimum point is -2, -10. You'll see that written over here. Now I want you to look at the completed square form. The 2 and the 10 are buried in there. Look back at the general form of the quadratic. You would have no way of knowing that there's a 2 and a 10 or a -2 and a -10 floating around there somewhere. So as soon as you write it in the completed square form, the turning point emerges in the algebra here in the function. But there's a couple of little things to be aware of. The x coordinate here with the 2, you've got to change the sign. The y coordinate is the constant stuck on the end, and in that case, the sign stays the same. So what I say in my head is change sign, leave sign. Change the sign of the x, leave the sign of the y, as in leave it be. Don't change it. Change sign, leave sign. Right, let's look at the one on the right. Now, the one on the right is an n-shaped curve. So as you would expect, it's got a minus, a negative x squared term. When we write this quadratic in completed square form, you can pause and have a go if you need more practice on that skill. It's going to end up looking like this, minus x minus 4 squared plus 20. Okay, the minus out the front, that just affects the shape, the fact that it's an n-shaped, it's a sag face graph. But we've still got the same thing with the turning point. It's a maximum instead of a minimum, and it's here at 420, and we have the second part of the bracket, change sign. The -4 in the bracket tells us that it's a +4 in the turning point, and leave the sign here. The plus 20 in the algebra part of this function is a +20 in the turning point. So here we've got a maximum turning point. Right, an exam tip for you is that in an exam situation, I don't think I've ever yet seen the words complete the square in an exam. That's the name of the technique. But we've got this thing that we need to be aware of, which is method selection. And method selection is when you're in an exam and you're looking at a question, or when you're doing your homework, you're looking at a question, and it doesn't specifically tell you what to do. How do you figure out what technique to use? Now, this is a problem the students have all of the time, where they say, I understand what I'm doing in class, but then when it comes to tests, I can't seem to get the marks that I feel I deserve. The reason for that is when you're in class, you learn a skill and you practice that skill. You know what the skill is, you know what you're doing. When it's all mixed up together in a test, how good are your method selection skills? When everything's mixed up, when you're not told explicitly what to do you know what to do? How do you decide which technique to use? So there are ways you can improve your method selection. So what I always like to do is I like to have links in my brain that if I see this form, if I see this little bit of algebra here, it might look like an x plus p plus q, or it might look like an x plus p squared minus q, or it could use any letters, and this bit at the end could be plus or minus, or maybe that's going to be a minus. Any kind of this completed square form in my head, I just go and complete the square. We've had a little look at the theory. We saw an exam tip. Let's now have a little look at doing some of these questions. So it builds on from our previous skill. Write the following in completed square form. So I've got x squared minus 4x plus 19. X squared minus 4x plus 19. Bracket squared x. And here we go with the sum. Half the coefficient of x minus the square, then the constant. Better put an equals in the start because there isn't an equals anywhere else. Tidy it up. On to the next part. Hence, write down the coordinates of the turning point of y equals x squared minus 4x plus 19. In the previous part, we completed the square for x squared minus x squared minus 4x plus 19. Now we've got the function y equals, so this, you could draw a picture with xy coordinates of this and it would be a U-shaped graph because it's a positive x squared and it has a minimum point. So if we rewrite our function y is equal to x squared minus 4x plus 19 in our completed square form of x minus 2 squared plus 15, you can see then that our turning point is going to be change the sign, keep the sign, 215. So what this would look like is it's a U-shaped graph with a minimum. I know it's a minimum because a U-shaped graph only has a minimum. It doesn't have a maximum. With a minimum at 215 there, that is what my curve will look like. All right. Have a little go at the question on the right. So that's a rough idea of what my quadratic curve will look like. There are some more details to be considered than that, but for at this stage of the course, that is all we need to worry about. So you can see that the completed square form is really, really useful in helping us to sketch curves and helping us to find their maximum and minimum. Because if you look at your original general quadratic form, there's nothing there that's going to tell you where the maximum or minimum actually is.